Hi, so in the last video we were able to create a class called ArrayBasedList, and in this class we create 5 operations: size, get, set, add, and remove. In this video we'll see how to improve this. So in the previous video, for the add operation, we said if the array is full, then we cannot add. We will print message list is full, but this is not good, because for the list we should be able to add as much element as we want. So how to improve this? We will improve this by doing the following. So if the n plus 1, if the elements that we will add is greater than the length of the array, we will call another function or another method called expand. So in this case, if the array is full, we will create another array with double the size. So this is what we will do if we want to add an element and the array is full. Let's do the method expand. So it's public void expand takes no input, and here we will create a new array of objects called b equals new array of objects, and the size of this new array, we will double the size of the old array. So this should be 2 multiplied by n. So currently we have n elements before adding the new elements. We want to create now array that have double the size, okay, 2n. And then we will create every element from, we will copy every element from array A to array B. To do that, we need to make a loop I less than n and I plus plus. I will loop over all elements, and then I will copy b of I equals to a of I. So with this, I copy all the elements in the array A to the new places in the array B. And after this, at the end of the loop, I will just change the name of the array B to BA. So A equals to B. And now A is pointing to the new array B. And with this, I expand the array. So now I have a new array with double the size of the old array. So I can add now more elements. If the new array is full, again I will call this method again, expand. So every time I add elements, I check. If it's full, I will create new array with double the size. So this is the method expand. I can do something similar in the remove. So when I remove elements, I could have like array of 1 million elements, and then I keep removing, and I'm ending up with only 10 elements. So I book a space for 1 million elements, but I only have 10 elements. So this is not good. I should avoid this, booking so much space for very few elements. So how to avoid this? Every time I remove elements, I will call a method called shrink. So shrink will check if, I will not call it all the time, I will check if number of elements is less than or equal a dot length divided by 3, I will shrink. So what does this mean? If the array is 1/3 full after removing the new element, if it's only 1/3 full, then in this case I don't need this so much space. So I have n elements, but I have 3n space. So the size of the array in this case will be 3n, right? So if I have 3n space, I don't need this so much space. I will do shrink. Shrink method is similar to the expand method. Let's write shrink method, public void shrink, and in this method again I will create new array called b. Now the size, I have now n elements and the previous size of the array is 3n. I will shrink it to 2n. So I will create a new array with size 2n, and then again I will do the same. I will just copy the elements from B to A, from A to B, sorry, and then I call this new array as A. So with this I will do the shrink. If you look, shrink and expand exactly the same method. Okay, so in both methods I create new array with size 2n, but here 2n will be double the old array, double the size of the old array. Here 2n will be less size than the previous array because the previous array is 3n. So but the code is exactly the same. So this is the expand and shrink methods. So now if I do some test, I will be able to add as much element as I want. So once I add and the array is full, the array will be automatically doubled and so on. And also if I keep removing elements, the array size will goes down with the time. So these improvements are very important to keep the list open to any addition or removal of the elements. So let's have a look to the slides to see what's going on. So the array-based lists, the advantage of using the array is that we can easily access elements in the array. We can easily change the value of the elements in the array. But the disadvantage is that the array has fixed size. So we cannot, if we want to add element, there is a fixed size. And if we want to add in the middle of the array, we have to shift. If we want to remove the middle of the array, we have to shift back. We have 5 operations for the array-based list. We already implemented these 5: size, get I, set ix, add ix, remove I. The fields we need, the variables that we need in this class is an array and integer variable n, and the constructor will initialize these fields. So we will initially create an array of size 10 and the variable is n, 0. So the size operation is very fast operation. It only needs one statement, so it's big O of 1. The get operation also big O of 1, we only need one statement. The big O of set is also fast, it's big O of 1. But the add operations, we need n minus I operation. Why? Because we need to shift all the elements from I to n. So this, we need to shift n minus I elements. So we need to create a loop from n to I. So that's why we need so much operation, big O of n minus I. And here expand, there is very expensive operation called expands, but we don't call it often. So we rarely call it. That's why we don't count it here. But we focus on this part, which is big O of n minus I. The same for remove. We need to do shifting back from position I to position n, which is big O of n minus I. Again, shrink, we don't consider it here because we don't do it all the time. We rarely do it. Expand, this is the code of the expand. It's big O of n because we need to copy all the elements from array A to array B. The same as string, actually they are the same method, so it's big O of n. And here is an example of how the array-based list will work. Imagine you have 4 elements in an array of size 6. If you add 2, if you add E at position 2, so first you need to shift E and D, and then you can add the new elements here at position 2. If you add R at position 5, we will add R at this position, R. And now if you want to add E at position 5, you don't have space. So first you need to double the array. This is array B. You copy the elements, and then you shift this R and you make space for E, and you add E. If you want to remove 4, we will remove this elements D, but we need to shift back everything. If you remove 4 again, you will remove this E and you shift back R. If you want to remove 4, then you remove R. Then you have a situation where you have 4 elements in array of size 12. In this case you need to shrink. So you will create new array with size 8, double the size, because you don't need this so much size anymore, and you copy the element. If I set 2i, you will set the elements at position 2 to be I. So if you think about the stack, we can have very efficient stack out of array-based list. The reason is that for stack we need 2 operations. Pop, we can easily make pop by remove n-1. We remove the last element, and the removing the last element is fast. We don't need shifting, so there is no space for this remove. And also push, we can push at the end using add nx. So you can push, add new element at the end. There is no shifting. This is also big O of 1. So it's very efficient to make stack out of array-based list, because you can make pop and push in big O of 1 operations. So as exercise, please implement the array-based list class and use it as a stack to reverse an input string. So you need to create a program that asks the user to input a string, and then the program should use a stack to reverse this string. And the stack should be made out of array-based list. Thank you, and talk to you in the next video.